Good morning, everyone. Welcome to the launch of the UKRI National Interdisciplinary Circular Economy Research Program. My name is Jin Xuan. So I'm a professor and head of Department of Chemical Engineering at Loughborough University. I'm also the director of the Center for Circular Chemical Economy. This week is a national launch week for the UKRI NICER program. So that's the Interdisciplinary Circular Economy Research Program. Within this week, we have a series of launch events for different research centers and also the hub. So today, we are focusing on the Circular Chemical Economy Center, but you are also very welcome to join other center events, such as the metal one, the metal for tech one in the afternoon, and the circular metal on Wednesday. And on Thursday, there will be the launch for the Circular Economy Hub. Okay, so before we go to the program, let's have some housekeeping introductions. So if you are encountering any technical issues, please use the chat to raise your question. So we have very nice technical support, Paul and Becky here, who will be working in the background to support you. And please do send a message if you're having any technical difficulties. The event is being recorded and a film will be made from the video footage. So if you do not want to be recorded, please just keep your camera off. And if you would like to tweet about the event hashtag across social media is NICER Program UK. So Smita, if you can just type the hashtag in the chat box so everyone can follow that. There has also been a participant survey sent through to you, I think, yesterday. So it will be really, really helpful if you can spare some time to complete the survey. Okay, so now I would like to spend around 10 minutes to have a very brief introduction of our center. So the name of our center is the UKRI Interdisciplinary Centre for Circular Chemical Economy. And within the center, we have a very nice team. So the center is in partnership with 7 institutions, Loughborough, Cardiff, Liverpool, Hereward, Sheffield, Newcastle, and Imperial College. So we are really an interdisciplinary team consisting of scientists, chemists, engineers, computer scientists, and social scientists trying to tackle the very complex grand challenge around the circular economy and the sustainability, particularly for the chemical industry. And on the right-hand side are our industrial partners. As you can see, these are also range from those multinationals, key players in the chemical industry, and also local SMEs, NGOs, and the government departments. So I would now like to invite all the center members to turn on your videos and just say hello to the audience. So hopefully you will find some familiar faces. Okay. Hello, everyone. So these are ranging from our co-investigators, center managers, administrative support, PhD students, and the research associates. So as I said, hopefully you will recognize some familiar faces here. All right, so Paul, please go back to the slides. Okay, next slide, please. Okay, so just some background. So this center is a part of a 30 million government investment funded by the UKRI Strategic Priority Fund with government departments such as DEFRA and the BASE to trying to move the UK towards a circular economy in the textile, construction, chemical, and the metal industry. So this is a aim of the overall program. And of course, we are more focused on the chemical industry. Next slide. Our vision is to transform the UK chemical industry's linear supply chain model into a fossil independent, chemical, climate positive, and environmentally friendly circular economy. How are we going to do that? So this will be achieved by creating a novel circular resources flow of olefin and their complementary feedstocks. So why we are focusing on olefin, because it is of overwhelming importance to the chemical industry, which is accounting for 70% more of all organic chemical products. So as shown in the right-hand side, we have designed several routes trying to convert different types of waste, biomass, and CO2 emissions back into olefins and their complementary feedstock, trying to create a circular resources model around the chemical industry. So in the next few slides, I just want to introduce what we're gonna do, or what research themes are covered within the center. So the first research theme is led by Professor Alex Cowan at Liverpool University. So we are looking at different new enabling technologies, because there's no one size fits for all approach. So we need to look at various new technologies to recover chemical feedstocks from end-of-life materials. So here just listed some of our initial focuses. So we'll look at, for example, combination of biological and thermal chemical processes, trying to convert waste biomass into alkanes and olefins. And we also look at the electrochemical methods, trying to convert CO2 emissions to olefin, either directly or indirectly. And we're also looking at some technologies which is at very low TRL levels, such as hydrogenolysis, so which we can convert waste polymers into mid-range alkanes. The second theme we are looking at is a whole system approach, which is led by Professor Benoit Chachelet at Imperial College, because we need to advance the knowledge on the evolving chemical value chain over the entire life cycle, instead of just looking at individual points. So the thing we are looking at in these themes are, for example, process integrations. So when we have the new technologies, we do want to look at how these technologies can be integrated into the wider infrastructure, or how the entire chemical sector can be integrated as a part of the wider clusters. And we will also look at life cycle assessment of any new processes or systems to make sure that the sustainability around the whole life cycle. And very uniquely, we also look at the social justice side of the transition towards a circular economy. So this part is led by Professor Peter Styron at Sheffield University. Last but not least, we also look at a theme of policy, society, and the finance that is led by Dr. Bin-Shu from Harvard Universities. So we realize there are also complex non-technical barriers around, for example, business motivations, finance gap, public awareness, and the policy incentive that need to be solved to deliver the circular economy. So within this theme, we will look at, for example, business models and finance solutions. We're also trying to develop campaigns to engage with the publics to enhance the public acceptance of the circular economy. And we're also very much working closely with policymakers to trying to use evidence to support the policy development. So these are pretty much the three research themes that we will be looking at in the next 4 years. Next, I would like to highlight some opportunities that you can collaborate with us. And we do really need to collaborate with a wide range of stakeholders and the research community, because a circular economy will not be possible unless a network of organizations are willing to work together as an ecosystem, including the stakeholders along the supply chain, but also the government, third parties, and the public. So there are different ways to work with us. So the first thing, and the easiest thing you can do, is to join our user and the stakeholder forum, from where you will receive our newsletters. You will be kept updated on opportunities such as workshops, training courses that will happen in the next few months. And you can also get access to our expertise. For example, we have joint PhD studentship available, and for industrial partners, if you're interested in particular technologies, there's always opportunities for consultancy work and joint R&D projects. Particularly for SMEs, there's a dedicated Innovate UK call, funding call that will be released very soon. So there are £2.5 million funding in total available across this year and the next year. So we will have an SME workshop planned in September to facilitate SME partners to apply for this Innovate UK funding. And if you are an academic member of the UK research community, there's also an opportunity from the CE Hub, so that's a circular economy hub, National Circular Economy Hub. So there will be a feasibility funding call released very soon. So it's we will fund several projects with each project around 50K pounds. So it's not a big project, but it's really to facilitate the collaboration and the participation from the wider research community to participate in this NICER program. So the funding call, the scope of the funding call will be to study the resources flows have already identified by the 5 research centers. You don't need to be collaborating with us before, but it will be always good if you talk with us, because one of the objectives is to enhance collaborations. So if you want to find more information about all these funding calls and the opportunities to work with us, please send us an email. So I have just listed our email address, circular.chemical@loughborough.ac.uk. And I think in the chat box, there will be also some information and links to particular funding calls. So that's a very brief introduction. So hopefully you will find it useful and you have a brief idea about who we are and what we're going to do in the next 4 years. Okay, so that's the brief introduction. And the next, we will have the keynote address from Professor Sir Richard Catterlow. So I would like to welcome Professor Catterlow. Before I hand over to Richard, I just want to make a very short and brief introduction. I don't think it need to be long because Richard is so well known. So Professor Richard Catterlow is a professor in material chemistry and catalysis at Cardiff and the UCL. He's currently the Foreign Secretary and the Vice President of the Royal Society. He has been awarded a knighthood in the Queen's Birthday Honours 2020. Professor Catterlow has worked for over 30 years in the field of computational and experimental studies of complex inorganic materials, pioneering a wide range of applications of computational technologies in solid-state chemistry. His group has been instrumental in techniques and code development, including research work on embedded cluster methodology for application to the study of catalytic reactions. Back to last year, Professor Catterlow has organized a series of Royal Society events discussing science to enable the circular economy, with topics ranging from fuels and chemicals, polymers, biotechnologies, and also techno-economic, societal, and environmental impact of the circular economy. All of them are very relevant to the remit of our Center for Circular Chemical Economy. So we are very proud to have Professor Catterlow as a co-investigator of our center. So today he will give the keynote in our launch event discussing the role of science in enabling a circular economy. So without further ado, may I hand over to Richard. Richard, thank you very much. You're muted.
Thank you. Thank you very much indeed for that very generous, kind introduction. And it's a real pleasure to be able to join this meeting today and to congratulate you and the leadership team on the launch of this very important consortium project. Now, I'll try and share my screen. Is that working? I trust that is working. So I'm addressing today an enormous topic, and that is the science that we need to enable a circular economy. Of course, this is the theme of much of the work of the CE Centre. I will only be able to talk about 1 or 2 issues, but I think perhaps the most important point that I will make is on this slide here. And that is that to achieve the circular economy, we need innovation in science and technology, of course, together with societal and behavioural change. We have some of the science and technology at present which will allow us to make progress, but if we are to achieve the circular economy, we do need new science and technology. And I think it's important to emphasise that point right from the beginning. Now, as was said, we organised, I think, a very useful and enjoyable and interesting Royal Society discussion meeting a couple of years ago on science to enable the circular economy. It produced a proceedings of philosophical transactions of the Royal Society, and those proceedings do treat in depth a number of the key issues. I'll really only be able to scratch the surface during this talk, so I do commend this issue to you. There's some really significant publications there. So the themes I'll try to address first are some of the challenges, and in fact the enormity of the challenges, but the type of scientific response that we're going to need. Towards the end of the talk, I'd like to emphasize the importance of life cycle analysis. That was mentioned in the introduction. It's a key component of work to achieve the circular economy. And then perhaps right at the end, a few speculations on new horizons for the field. Let's now start thinking about the challenges and the science. And I'll start with some rather general points that relate to linearity versus circularity, sustainability and green chemistry. We're probably aware of all these issues, but I think they're worth emphasizing. Then we'll look at two major challenges, again, that we're all aware of, and that is the development of a circular polymers and plastics economy, an absolutely key challenge, and the challenges around CO2. I hope also to refer, as the talk progresses, to issues relating to biomass utilization and to the development of greener ammonia, which I think is a key challenge. Now, let's just think first about linearity versus circularity. I should, by the way, at this stage, thank Matthew Davidson from the University of Bath, who has helped me with this part of the talk. What we have on the left-hand side essentially is largely what we're doing now. That is, we take natural resources, really a mixture of technical and biological materials, we take them, we make products, and at the end of the life, we largely dispose of those products. Now, we are making progress on recycling, but this is not a bad description of the majority of what we're doing at present. Now, as you know, what we need to do is to transform that whole process as we develop the circular economy. We need to, with our biological materials, yes, to make and consume products, but then the waste we need to do to enrich to get this circularity. With our technical materials, again, we need to make and use products, but then we need to return them. Now, that is easier said than done. That is essentially the challenge. Here in a little bit more detail is what we need to do. A circular economy is an industrial system that is restorative by design. And I think that sentence needs emphasis. Restorative by design right from the beginning of the whole system. With technical cycles, we start with them being increasingly powered by renewable energy, but then we recycle, we refurbish, we reuse, and we maintain. With the biological materials, again, we consume, but then after consumption, we need to extract biochemical feedstocks using a variety of procedures, and we return and enrich. So just let me repeat, the whole system needs to be restorative by design. This slide just emphasizes the point that we need loops, we need reusing loops, we need recycling loops, and we need renewing loops. So I think we all know that, but we do need to emphasize this, and we need to emphasize the challenges. Now, a few words about sustainability. I think the 1987 definition of sustainability is hard to improve on, the ability to provide for the needs of the present without compromising the ability of future generations to meet their own needs. In my view, that is a very good and very eloquent way of summarizing the needs for sustainability. And again, economic development, social development, and environmental protection are all integrated and mutually reinforcing pillars. Natural resources we need to use at rates that don't deplete supplies over the long term, and residues should be generated at rates no higher than the environment can assimilate. We all know these, but they're worth emphasizing. Now, let's just think for a moment about the Sustainable Development Goals. These are, in my view, a really important and key aspect of the way in which we're going to, ways in which we have to develop our planet. They're, as it says here, a shared vision of humanity and a social contract between the world's leaders and the people. Now, I'm not going to go through all the SDGs, but I am going to emphasize that many of them will require scientific and technological innovation if they're going to be achieved. And I think the scientific community needs to give even higher emphasis and profile to the SDGs. We're picking out here 3 that are particularly relevant to the theme of the circular economy: to build a resilient infrastructure, promote inclusive and sustainable industrialization, and of course, foster innovation; to ensure sustainable consumption and production patterns; to conserve and sustainably use the oceans and marine resources. These are all very, very key components of the achieving the circular economy. And I rather like this concept here, a safe and just space for humanity. The idea is that we have a social foundation that has key social needs such as education, employment, and key physical needs, food, water, energy. And those provide this foundation, but then we have a space within which humanity can live safely and sustainably, but there is an environmental ceiling to that space. So we need to stay within this safe and just space. And of course, the circular economy is striving to do that. Now, a few words about green chemistry. Again, we're all familiar with green chemistry and absolutely integrally involved in the circular economy. It's about displacing stoichiometric technologies with greener catalytic alternatives. It's about the change from fossil-based to renewable bio-based manufacture. It's about the transition from an unsustainable economy, of course, to a circular one. And this again emphasizes designs, products, and processes with conservation of resources in mind. So these are all important concepts. I'm taking this from a very important article from Roger Sheldon, published in Green Chemistry. Now, let me, having discussed these rather generalities, move on now to some of the challenges. And it's impossible to talk about the circular economy without discussing the enormity of the plastics challenge. And again, I'd like to thank Matt Davidson for helping me to put this part of the talk together. Some of the figures are pretty staggering. 1 million plastic bottles bought globally every minute. Each person on the planet will generate twice their body weight in plastic weight every year if we have a business as usual scenario by 2050. So these begin to allow one to feel the scale of the challenge. Here are some data, a little bit out of date actually. On the left-hand side, we've got data for 2014, 311 megatons of plastic production. We look at what's going on in the oceans. There's about a 1:5 ratio of plastics to fish. Plastics are about 6% of global oil consumption and 1% share of the carbon budget. The business as usual scenario would mean that the plastic production would almost quadruple by 2050, which isn't that far away. That the ratio of plastics to fish in the ocean by weight will be 1:1. Plastics will be 20% of the oil consumption and 15% of the carbon budget. Of course, this is unsustainable completely. Just let's look at the plastic waste generation. Again, this is a business as usual scenario, and we see the amount of waste increasing dramatically, even with various approaches such as incineration and recycling. So there really is an absolutely enormous problem here. Growth of plastic waste, 1 gigaton per year by 2050. Just here allows one to see some of the growth of the business as usual scenario broken down into region, and we see very, very substantial growth projected for the Middle East and Africa as their economies develop. On the top left-hand side of this slide, we have a kind of interesting commentary on the current chemical sector, which if you look at that, you see is largely taking fossil-based feedstocks, converting them into thermoplastics, other products, and fertilizers. Of course, then we will have to change the feedstocks, and that is the scale of the challenge. I just want to emphasize the challenge a little bit more. This is largely what we're doing at present. I say that the data are a little bit old, but this relates to packaging plastics. And we see that actually only 14% of this was a few years ago are collected for recycling, and quite a lot of loss in the process of recycling. We see a high proportion going to landfill, quite a lot going to incineration, and a large amount, an alarmingly large amount of leakage. And again, just to bring the point home here, we're looking at the kind of total plastics consumption, primary production, we see on the left, in-use stocks in the middle, discarded on the right, and the proportion of recycled we see is relatively low. So we do have an enormous challenge, and this is what we need to move to. We need to move to a system that recycles and reuses. And there will be major technical challenges in recycling, in reusing, and in designing and production, and technical challenges in minimizing leakage and developing, where appropriate, energy recovery. In responding to these technical challenges, catalysis and processes for enhanced effectiveness will be absolutely vital. They need to be robust and benign. We will need for things like self-healing materials, and we need programmed degradation and chemical recycling, and we need design for reuse. Right, now here's just perhaps a brief glimpse of the kind of thing we need to do. Chemicals and polymers require a hydrocarbon toolkit. That hydrocarbon toolkit at present is largely provided by petrochemicals. They provide an oxygenated toolkit, which we can provide from renewable platforms. But what we need to do is replace the petrochemical platform by a renewable hydrocarbon platform. But this is something which is feasible, but it's something that this centre and others need to focus on. Let me say a few words about the CO2 challenge. Again, we're all aware of the huge challenge of CO2. And the first component of the CO2 challenge, of course, is climate. But then there are other important issues that sometimes don't receive, in my view, the attention that they should. And that is the fact that we're going to need to use CO2 as a carbon source, because we can't go on indefinitely using petrochemicals as a carbon source. And we need to develop sustainable hydrocarbon fuels. Now, we're all aware of the CO2 challenge regarding climate. This slide illustrates actually what we need to do. On the left-hand side, you see the global, with total net CO2 emissions at present. We need to get those down to net zero over not a very long period, 30 years, if we're going to limit global warming to 1.5 degrees. It's a huge challenge. I believe it is a challenge to which humanity can respond, but it is a huge challenge, and it is worth emphasizing that. But as I said, there are other aspects of the CO2 challenge. CO2 as a carbon source in the post-fossil fuel era. We will need to do that. We will need to use CO2 as CO2 as a base for developing chemicals and fuels, and CO2 hydrogenation, a key chemical process, will be needed to produce fuels and chemicals. So I'd like now just to give a few glimpses of some enabling science, some of which I've been involved in, and emphasize the key role of catalysis. And the first is work at Cardiff on utilizing glycerol. The second is work on the Harwell Centre on carbon dioxide hydrogenation. And the third is work that I've been involved in together with Justin Hargreaves at the University of Glasgow on investigating catalysis for greener ammonia. First, let me highlight this very nice work, I think, on glycerol, led by Nick Dummer and Graham Hutchings at Cardiff. Now, glycerol, I think, as you probably know, is a waste product from biodiesel production. It actually has great potential as a feedstock for useful chemicals, but the glycerol you obtain when you produce your fatty acid methyl esters from triglycerides is usually diluted, and it contains impurities. What this work aimed to do was to develop catalytic processes that would convert the glycerol into methanol, which you could then feed back into the whole process, making it circular and sustainable. And what they found was that, in fact, a range of metal oxide catalysts could affect this very interesting catalytic chemistry. Cerium dioxide, which is a very versatile oxide catalyst, can affect the conversion of glycerol into methanol. The selectivity is not fantastic, but this is nevertheless a useful process. So not only can CO2 do this, but it actually can work with the dilute and impure feedstock. It's better if you have a pure solution. That's what the data here is showing. It's better if you have a pure solution, but the catalysis does work with the real feedstock. So I think this is a really significant development, because what it says is you can take this glycerol, which isn't otherwise much use, you can use it to generate methanol, which you then feed back into the process. So it's a nice piece of circular chemistry. And I should emphasize, I wasn't involved in this. Nick Dummer, Graham Hutchings and colleagues at Cardiff led this work. The second is some work, but actually fundamental work, but we will need fundamental work on CO2 hydrogenation. We will need to understand the mechanisms of these reactions if we're going to optimize them. So here I'm highlighting work of Michael Hyam, who works in the Harwell team, the Harwell Catalysis Centre. And Michael has done a very in-depth survey of the mechanisms of CO2 hydrogenation on copper, but on other catalysts. It's a complex mechanistic route, and I'm not going to have the time to take you through it, but it's been explored in detail. The process starts with CO2 either dissociation or direct hydrogenation. We think on copper, it's direct hydrogenation. It goes through a range of intermediates, formic acid, formaldehyde, and methanol is the final product. But we in fact know that the more effective catalyst, in fact, is copper deposited on zinc oxide. And as part of this work, we have shown that you can activate copper more effectively on nanoparticles of copper deposited on zinc oxide. So that's giving us real insight into the catalytic process. And this is, of course, all computer modeling work. And in my view, we will need the guidance from computer modeling if we are going to optimize the catalysts that we need for these essential chemical processes. Let me take my final example, one I really like, and that's the mechanism of ammonia synthesis. It's again computational work on transition metal nitrides, the move towards greener ammonia. And here I'm highlighting work of Konstantinos Sin, Alipur Yazdi, work that we've done in collaboration with Justin Hargreaves. Now, we all know the background to this. We need, ammonia is absolutely vital. And ammonia is made by reacting nitrogen with hydrogen, usually hydrogen obtained in fact from fossil fuels. And we use the famous Haber-Bosch catalytic process. We do need to do moderate temperatures in order for this catalysis to proceed, and we need high pressure. The whole process is energy intensive, and we need to try and find a catalyst that works at lower temperatures and pressures. And very nice work of Justin Hargreaves' experimental work, in fact, has shown that a cobalt molybdenum nitride catalyst can, in fact, do this. It can synthesize ammonia at lower temperatures and pressures. But that's just a few words about the Haber-Bosch process. I mean, the Haber-Bosch process is an absolute milestone in the development of catalysis and chemistry. And if you ever want an illustration of the importance of both catalysis and chemistry, you can point out that the nutritional requirements of something like 40% of the global population are dependent on nitrogen that is fixed by the Haber-Bosch process. But the Haber-Bosch process is, in fact, brute force chemistry. The mechanism is rather simple. You absorb nitrogen and hydrogen on the metal surface, and you have to break the nitrogen-nitrogen bond. So you have to break the strongest bond in chemistry. So as I said, this is brute force chemistry. Can we replace it by something a bit cleverer? Well, what this computational work suggested was that we could. If we take these cobalt molybdenum nitrides, they rather easily make vacancies on their surface. And what the computational work showed was that those vacancies can trap nitrogen molecules. Once they've trapped nitrogen molecules, those molecules are now activated, and they can start to pick up hydrogen atoms that are adsorbed on the surface. They pick up hydrogen atoms without dissociation, without breaking that nitrogen-nitrogen bond. And so we can hydrogenate the nitrogen molecule, and then it dissociates when that NN bond is only a single bond, which is much easier to break. So this is an associative, non-dissociative mechanism. And we believe that developing non-dissociative mechanisms is the key to developing greener routes to synthesizing ammonia. This just shows that you can follow the details of the mechanism. It's an energy profile. You can identify all the intermediates. But the take-home message is that low temperature ammonia is possible on this catalyst. It has a large number of nitrogen vacancies, and it can occur under milder conditions because it's an associative mechanism. Well, let me now move to my next theme, which I'll only treat very briefly because I think we're all aware of this. And this is the environmental aspects of the circular economy and the need for life cycle analysis. And I'd like to highlight the work here of Adisa Azabajic, the University of Manchester, who has done very, very interesting and important work in this field. And she kindly let me have these slides. And she emphasizes that what we need is a systems approach and life cycle thinking. Yes, we have resources. We need to think about the economic costs, the social impacts and the social benefits, the economic benefits, but then the environmental impact. And then again, I think I've showed you this slide again. We need to build in restorative processes, regenerative and restorative processes. Now, I'm just going to give you one example from many which Adisa has investigated, and that is just concerns food waste to digest, compost, burn, or bury. And in fact, a very large amount of household food waste is generated in the UK, quite a significant proportion of which is managed. And these are the ways in which you can manage it: anaerobic digestion, in-vessel composting, incineration, landfill. So you need to do an LCA, a life cycle analysis, to decide what is perhaps the most appropriate approach. And what, I'll not go through the analysis, but just go straight to the results. In-vessel composting is the worst option for most impacts, which, you know, surprises one. It certainly surprised me, but when you do the LCA, that is what you find. Anaerobic digestion is the best option for carbon footprint. It's much higher acidification, and in fact, greater benefits achieved through waste prevention. So I think just for this one example, it illustrates the importance of building in LCA to the whole analysis. Now, finally, I say some new horizons. Here I'm highlighting some work by a colleague at the Royal Society, Jack Pilkington, working in the policy team at the Royal Society, who has been studying issues relating to animate materials. It's really fascinating. Materials are typically inanimate, but animate materials made by humans aim to mimic the properties of nature. That is, they have self-healing properties, they harvest energy, and they repurpose at the end of life. And again, a lot of work here, I haven't time to go into in detail, but what this is saying is build, as people develop these kind of materials, a really fascinating challenge, build in sustainability and circularity at the outset. Animate materials could help build a future, but they won't by default. We need to build in environmental impacts at the research and design stage. That again is just emphasizing the importance of LCA. Well, here are now some final reflections that I'd like to leave with you. They are that we need to respond to the scientific challenges, but in our response, we want first to exploit the latest techniques and infrastructure. Next, I think we need to use all the digital capabilities. And thirdly, we need to collaborate and coordinate. Now, I know the centre is going to do all these things, but let's just talk about the latest techniques and infrastructure. Here, we're looking at an aerial view of the Harwell campus, where we have our Catalysis Centre. And you'll see that lovely circular feature there, which is the diamond light source. More in the foreground, you see the ISIS neutron source. Of course, there is a central laser facility as well on this fantastic science and innovation campus. We have a Catalysis Centre there, and what we have learned over the last 6 or 7 years is that these world-class facilities, synchrotron, neutron, and laser, have a major contribution, are making a major contribution to our work on catalytic systems. So this is just one illustration. Let's use these and other fantastic techniques and facilities. Let's use all the digital facilities available to us. I mentioned during my talk the work that my team does using computational modeling techniques. We develop software such as the QMMM methods, which we're developing with colleagues at Daresbury and Bristol. But computational modeling, which was a speciality in catalytic science, is now dispersed throughout the discipline. You go to a conference on catalysis, you'll find well over half the papers will be making use of computational methods. But there's much more to digital technologies. We've got computer modeling, but now we have the fantastic tools of AI and machine learning. And these digital technologies will be absolutely vital to our field. But then my third point was we need to collaborate. And I'm just going to mention here 2 initiatives that I think this centre can interact with. The first is this Innovative Centre for Applied Sustainable Technologies, ICAS. And again, thank you to Matthew Davidson for letting me have this slide. It's a new 70 million Research England funded centre. Partners, you see, universities, catapults, LEPs and investors, a lot of company members. And this is just starting. It's being led very much by University of Bath and University of Oxford. This is the kind of initiative that we need to interact with. And let me say a few words about the UK Catalysis Hub that I've mentioned during this talk, because the hub, I think, must have strong interactions with the CE Centre. This is a current structure of the UK Catalysis Hub. It's got a core component led by Graham Hutchings, and then it's got 3 scientific themes. The first is optimizing, predicting and designing new catalysts, which I lead. This is based on the Harwell campus. Catalysis at the Water Energy Nexus, led by Chris Hardacre in Manchester, and catalysis for the circular economy and sustainable manufacturing. But of course, these different themes all interact with each other. And let me finish with just some more details about the Science 3, Catalysis for the Circular Economy and Sustainable Manufacturing, led by Mark Davidson. And this, of course, is based on the premise that catalysis is central to the circular economy of keeping molecules in play. Using waste CO2, plastics, recycling, reuse, bio-based resources, non-toxic and abundant additives. And here we highlight some of the current projects. I'll not go through them all, but you will see how very relevant they are. Sustainable hydrogenation catalysts, reframing plastic waste as a resource, CO2 to methanol via a catalytic membrane reactor, catalytic upgrading of Cardiff. So really, really very relevant projects. So again, Catalysis Hub is an initiative with which the CE can collaborate. So I'd just like to conclude with acknowledgements. I'd like to thank the people who helped me put the talk together: Matt Davidson, Adiza Azabajic, Nick Dummer, and Jack Pilkington. I'd like to thank the people whose science I've referred to: Konstantinos, Sinalipur Yazdi, Michael Hyam, Justin Hargreaves, Graham Hutchings. I'd like to thank the CE Hub team for their leadership in developing this exciting project, and of course to UKRI for their funding. But finally, thank you very much for your attention.
Thank you very much, Richard, indeed. So that's really, really informative and insightful this keynote. So I would like to welcome questions from the audience. So if you have any questions addressed to Richard, please use the Q&A function in the Zoom. So Richard, we have received a few questions so far. So if I can just read out these questions and if we can answer them. So the first is from Christina. Thank you, Professor Kettler, for your presentation. So she has a question concerning the use of renewable energy. Is it really possible to use only renewable energy for energy consuming processes in the future?
Well, it's a very important and very general question. We're not going to be able to move to renewable energy overnight, but we will be able, I believe, to transition over a period of 20, 30 years to a system that is predominantly renewable. I mean, others may wish to comment on this. But I need to emphasize, this is a process that will have to be staged. We are dependent at present on, to a large extent, on fossil fuels, and we cannot turn those off. But we do need, over the next 20, 30 years, to move to an energy system that is predominantly renewable. But thank you for the question. It really is a very important one.
Okay, thank you, Richard. So the next question is from Jeremy. So Professor Kettler, you mentioned two routes to renewable polymers. One is through the bio-oxygenate, and the other is from hydrocarbons. So which might be the preferred routes, considering like the yield, product performance, etc.?
Well, again, it's a good question. I don't think you can give any kind of definitive answer. I think thanks for the question. What I would say is that what you need to do, again, is to do the LCA, depending on the particular process that you're doing. If you do the LCA, that will guide you as to which route is going to be preferred. So let's emphasize that. LCA, absolutely vital in this field. But thanks for the question. And my response is, depending on the problem, this will depend on the system, the problem, and to answer the question, you will need to do LCA.
Yes, thank you again, Richard. So the next question is from Chung. So thank you, Professor Kettler, for the very informative and inspiring talk. Chung has a question regarding the novel catalysis or catalyst for low temperature ammonium synthesis, which contains like critical metals of cobalt. Is it possible to achieve the same target without using other catalysts that do not contain cobalt?
Excellent question. And the answer to that question is, this is work in progress. Together with Justin Hargreaves, Bill David, we currently have, in fact, an EPSRC funded project that is just started and aims to do just that, try and find alternative, building on the knowledge that we've obtained from the work on the cobalt molybdenum nitride, trying to find alternative transition metal nitride systems that will operate via this dissociative mechanism. So very, very good question. And I say, work in progress.
Okay, thank you. So the next question is from Marlon. Thank you for your for this insightful presentation. How do you envisage the role of surface engineering technologies for green chemistry?
Well, I think, surface engineering technologies.
Surface engineering techniques, yes.
I think there'll be key importance. As I said at the end of my talk, we need to use all the relevant techniques that we have. And I think those techniques will be very important in the field. So thanks for that question.
Okay, so the next question is from Jeff. Professor Kettler, thank you very much for your presentation. Green chemistry is a broad term. How does your work influence the proposed government chemical strategy and its embracing green chemistry? And how is the CE Hub linked to the government chief scientist network? So there's an effective science policy engagement. So probably I can answer the second part, like the CE Hub. But Richard, if we can discuss how the your work influences the upcoming government chemical strategy, that will be good.
Well, I mean, we aim to, I think this is more, to be quite honest. I mean, it's a good question. I think it's more of a question for the panel discussion as to how we influence policy. What I can say is that we have a number of routes for, in particular, routes, for instance, via the Council for Science and Technology, routes via the Government Office of Science and Technology. And I can tell you that they really do listen. In the Royal Society, we have a very effective policy team. They have actually recently produced a whole set of briefings relating to the role of net zero. Those briefings are beginning, I think, to have influence with policymakers. So, it's not a simple question, but I think policymakers are listening at present to scientific needs in this area, and it's a job for all of us to do. But I mean, over to you, Jin, perhaps to give your perspective.
Yes, indeed, fully agree with you, Richard. So, Jeff, regarding your second part of the question, how the CE Hub is linked to the government chief scientists network. I mean, we are working closely with different departments of the government. For example, from the proposal shaping stage, for example, DEFRA is playing a very important role. But now, since all the centers are developing and the CE Hub is coordinating some policy engagement with different departments, such as not only DEFRA, but also Base Environment Agency, etc. So you will hear a bit more on the insights of how we work with policymakers in the panel discussion later. Okay, so because of the time, I can see there's a lot of questions coming. Probably I can only take two more. So the next from Greg, do you see a significant role for direct air capture CO2 in the future? Is this a key part of a circular economy?
I think the answer to that question is yes, I do see a significant role for direct air capture. There are a lot of issues surrounding direct air capture. I'd be very interested to have Peter Styring's view, but I think developing the direct air capture technologies is going to be an important part of achieving a circular economy. But I would appreciate other comments there. Sure. But thanks for raising it. I think it's an absolutely key point.
Great. So I think we can discuss this a little bit more in the panel discussion. Again, Peter will be one of the panel members. So I will take the last question. So I saw there's more questions coming. So you can also save the questions to the panel discussion, which we will start very soon. So the last question went from Lynn. Thank you for the informative talk. How about the energy efficiency in CO2 recycle compared to the hydrogen economy that move away from the carbon-based energy routes? So could you comment a little bit here, Richard?
CO2 hydrogenation we need because we need carbon-based products. That is why I was emphasizing the important role of CO2 hydrogenation. We need carbon-based chemicals. I actually do think that CO2 to fuels is going to be an important component of the future fuel and energy mix. But as well as developing fuels, we need CO2 chemistry we need CO2 as a source of carbon to develop carbon-based products. But again, it's a very good question and one that I think we could discuss in the panel.
Great. Thank you very much, Richard, for your time in giving us that very insightful keynotes and also taking questions from the audience.
Well, thanks very much for the questions, because nearly all the questions raised major issues that we could have discussed for a long time.
Exactly, exactly. So hopefully some of the conversation can be continued in the panel discussion. So let's move to the next part of this event. Again, thank you very much, Richard. So then we will now move into our panel discussion with our academic and industrial leaders on the topic of the relationships and nexus between circular chemical economy and net zero. So the panel will be chaired by Dr. Sheena Hinoka. Sheena is a knowledge transfer manager in the materials chemistry at KTN. So she's also the chair of the strategic advisory board of our center. So Sheena got her PhD from Imperial College in 2013. After that, she moved into industry as a research scientist at Johnson Matthey and later took a project management role there. And Sheena joined KTN as a knowledge transfer manager in 2019 in the chemistry and industrial biotechnology team. Her current area of interest includes in catalysis, hydrogen batteries, sustainable aviation fuels, alternative feedstocks, again, very much fit with the remit of our center. She is also working across government, industry, and academia to identify strategically important area for the UK and develop recommendations for intervention. So without further ado, so I will hand over to Sheena to start the panel discussion.
Thanks very much, Jin, for that really nice introduction. I'm really pleased to be here this morning to sort of combine this and lead this panel, which consists of industry and academia, to discuss a really important topic. So morning, everyone, and thank you for joining us today. As Jin said, I'm Sheena Hindocha from KTN's Chemistry and Industrial Biotechnology team. If you haven't heard of us at KTN, we create diverse connections to drive positive change, and that is impacting environment, society, and the economics across the UK. I'm really pleased to be here today, and we've got a really great panel lined up to talk to you. So we're just going to crack on with some introductions before we get into the questions. If you do have any questions for the panel, please pop them in the Q&A box and we'll pick them up as we go along. So firstly, I'd like to introduce Professor Peter Styron from the University of Sheffield.
Thanks, Sheena. So yeah, I'm from the University of Sheffield, Professor of Chemical Engineering and Chemistry, and also an Associate Fellow in the Understanding of Politics at the Sir Bernard Crick Centre. So I also head the Styron Group, as the name suggests, and I've got a very talented team of people working on life cycle assessment, techno-economics, social impact analysis, policy development, and even direct air capture, as one of the questions came up. We have a meeting tomorrow where we're looking to install a plant. I also work with Unilever as part of their home care program on clean future, and you'll hear more about that later. This centre is so important. We have to move now. It's a case of reuse it or lose it. We really need to push the boundaries of what we're doing. And the importance of life cycle assessment, as Richard said, is absolutely paramount. And my group, together with the Global CO2 Initiative, have started to work on the harmonised guidelines for life cycle assessment across CO2 utilisation, which can be transposed to any other technology as well. Once you have the methodology and you know the boundaries, then that can be universal. So looking forward to this discussion. So thanks, Sheena.
Brilliant. Thanks very much, Peter. So next, I'd like Bing Zhu from Heriot-Watt University to talk to us for a little minute.
Morning, everyone. My name is Bing Xu, and I am an associate professor in finance at the Heriot-Watt University. It is my great pleasure to join today's panel discussion. My research is around banking and finance, energy economics, and decision analysis. I have been worked on several multidisciplinary energy projects, and super excited to see my experience in business and finance, and can also play an active role in those technology centers and projects. For our center, I lead on theme 3, policy, society and finance, in which we aim to provide the stakeholder co-created knowledge on barriers, challenges and opportunities to enable a successful transition to circular chemical economy around 4 main aspects. So first of all, we need to understand how business create, deliver and capture values by advancing circularity. And secondly, it is well known that improved circularity cannot be achieved without substantial level of finance. And despite the strong momentum in the investment community, there's still a huge financing gap. So we're very interested in finding out how we can mobilize a private investment. And thirdly, beside the business and finance community, it is critical to understand the public's perceptions of and responses to circular chemical products. And we believe that increased attention and positive attitudes towards sustainable products could positively influence the market momentum, stimulate demand and supply. And finally, we would like to highlight areas that require some government interventions, identify effective policy to accelerate the circular chemical transition. So I look forward to working with everyone over the next few years, and together we'll be able to identify the problems as well, and also deliver real world solutions to overcome some of those obstacles. Thank you.
Brilliant, thanks very much, Bing. Next, I'd like to invite Dave Robson from NEPIC to talk to us for a minute.
Good morning, everyone. I'm Dave Robson, Technical Director at NEPIC. NEPIC's a cluster organisation for the process sector in the North East. So we work with industry and the supply chain, and industry has worked quite hard over many years to reduce environmental impacts. I think one thing, if we look back, we've made an awful lot of progress. The problem with that is it means the stuff which remains to do is much harder. And that's where working together and looking at a range of technologies and also some of the business models and the finance implications around that is so critical.
Thanks very much, Dave. Next on our panel, we have Louise Keller at Roper and Bankers for Net Zero.
Hi, thank you. I'm really pleased to be here. So I am the CEO of Volans, which is a small boutique think tank and strategic advisory. We work with multinationals on transformation across sectors like chemicals, energy, fuels, infrastructure, retail and banking. Clients like Neste, Novartis, Acciona, Covestro, Unilever, Selfridges Group, Rakuten, so quite wide. I've spent most of my career working in businesses or with businesses on innovation strategy, and in particular on circular economy business models. And then have got involved more and more with Global CO2 initiative that Peter mentioned on the carbon capture and use acceleration. And I'm also co-founder of the Bankers for Net Zero initiative, where we bring together banks, industry and policymakers to unlock kind of capital flows that are needed to really finance net zero here in the UK. So I'm particularly interested in that intersection between science, industry, finance and policy. Thank you.
Excellent, thanks very much, Louise. And lastly but not least, on our panel, we have Ian Howell from Unilever.
Hi, good morning, everybody. So I'm Ian Howell. I'm a materials science director for Unilever. Unilever is one of the sort of world's largest fast-moving consumer goods companies with a very large footprint in the UK. Our interest, or my interest, is very much, as you can see behind me, delivering our clean future ambitions and Unilever's purpose of making sustainable living commonplace. So for home care, a billion people use our products every day. And to Richard's point earlier on, if those materials and products that we use aren't circular and aren't sustainable, then we really are letting down the future society. So it's all we're looking after today, but not after tomorrow. And so we've called out as Unilever that we will be net zero by 2039 in scope 1, 2 and 3 emissions, which is incredibly challenging, but nevertheless something we have to do. We've also called out that by 2030, we will have no fossil carbon or virgin fossil carbon derived materials in our products in home care. Again, all of this points us towards a world with circular carbon at its core, and that's my interest in this centre. I should also declare an interest. I chair a group with the Chemistry Council in the UK. Some of you may not have heard of the Chemistry Council, but look it up on Google. So the Chemistry Council also has a Sustainable Materials for Consumer Products group. It's a cross-industry group that is really driving on how do we in the UK deliver a sustainable materials industry. So that's my interest and who I am.
Brilliant, thanks very much, Ian, and thank you all for joining us this morning. I really like that we've got such a diverse mix of perspectives on this topic, so hopefully we'll get into some good discussion. I can already see some questions coming in which delve into some of the detail quite quickly. Keep those coming in and we'll pick them up as we go, but I'd like to take Chair's prerogative and just start with a couple of high-level scene setting questions so we can get some different perspectives on the topic. So just going to go to Peter first. Can you explain from your perspective why we should be moving towards a circular economy for chemicals?
Well, the reason, in my opinion, is that we've been moving on the linear path for far too long. And in fact, if you go back to, I think it's 1979, Ad Lansing in the Dutch government said we have to adopt a waste hierarchy. So the first thing is avoid. So don't produce the waste in the first place. The worst thing you can do is landfill. So in between that, you have energy use, but you also have recycle and reuse. So if you look at the IEA report and the IPCC report, they say we have to stop using fossil carbon. Not we should, we have to stop using it. And if we need carbon, so we need a replacement. And the only way to do that is to recycle it. So I think we have a duty to the planet, to society, and to grandchildren to use the carbon we have and not waste it. So someone mentioned Back to the Future. We did this in the APPG, the All-Party Parliamentary Group on Energy Studies. You have to look back before you can look forward. And you know, if we look back to rationing, if we look back to austerity, if we don't act now, we'll get into a much worse situation.
Yeah, brilliant. Thanks very much, Peter. And Bing, I'd like to bring you in here to consider your views.
Yeah, thanks, Gina. So yes, I definitely echo with Jean, Professor Sir Richard Catlow and Peter. So the chemical sector is incredibly important to the UK economy, and we've seen that it is the second largest manufacturing industry by value added. It offers an over 150,000 direct jobs across 3,600 companies. However, despite its importance, and the current industry is highly linear, and business still using the take, make, and dispose approach. And we cannot continue on the business as usual scenario. And moving towards a circular chemical economy is not an option, but an inevitable response to a growing demand and adjusting UK's emission accessible growth. And we need to rethink our production consumption system. And this can not only reduce the dependency on imported virgin petrochemical feedstocks, and also reduce reliance on waste storage or exports, and contributing to some of the relevant national targets such as net zero and 2050 year environment plan. And I think we also need to establish a regular assessment to track progress as well. Thank you.
Brilliant, thank you, Bing. And Ian, I'd like to come to you because we've already mentioned Unilever's massive ambitions within this space. You clearly believe as a company and an individual how we should move forward. So I guess not just around why we should move forward, but what is the biggest opportunity for you that Unilever see in this space?
Yeah, so I think again I come at this from the business angle, if you like, which maybe people don't think about too much. So I have a number in front of me which is sort of staring me out. So in the heart of the coronavirus crisis last year, Unilever did a global survey to ask about consumers what were the things that worried them most. And actually the figure that came back, which astonished us, was 71% of the population that we sampled said that climate change was as serious as COVID, right in the middle of the COVID crisis. And we were surprised. And actually, there are many surveys like this. So plastic waste, climate change are the biggest global environmental concerns that people have. And I think the thing that's shifted is people now realize it's about them. It's not this thing about the planet which is going on out there. It affects me. And that translates through to consumer purchase. So consumers will frequently tell us, if you're doing a good job on the environment, we will consider buying your product. You still have to have performance and you still have to be affordable, but we will at least consider buying your product if you're doing a good job on the environment. If you're not, then something like 78% of consumers say we have stopped using a product because it did something wrong for the planet. So it's incredibly important from a business perspective that these commitments we've made as Unilever absolutely make business sense. And circularity, as Richard pointed out, if it translates through to climate change and if it translates through to water and all these other things that consumers are concerned about, is absolutely business sense. So that's why I'm it really is kind of, it absolutely makes logical sense to do this.
Yeah, those numbers are amazing. Actually, I never thought they would be that high, but that's incredible, and also brilliant that consumers are moving in that direction and helping drive the change. And so I guess we've heard through those perspectives about the opportunities, but maybe we could touch a little bit on the challenges around this. We've heard some of those through Richard's brilliant presentation. Dave, I just, from a kind of a cluster and a NEPIC perspective, what do you see as the biggest challenges that are associated in moving towards this circular chemicals economy?
I actually see a few challenges. Some of them are quite obvious in terms of a change needed in the business models, because we're going from a structure where a lot of the linear use, a lot of that was actually funded and paid for by different bodies, such as the extraction of the materials and the waste disposal, whereas circular economy may well be overall cheaper, definitely better for the environment, but a lot of those costs are focusing back on the manufacturers. So challenge is being able to address that and for industry to remain cost competitive. I think equally there's a huge reliance on people at the end of the life cycle being able to put those back into a recycling mechanism so that they can then be taken forward and used as, again, raw materials and intermediates. I think also we have a lot of challenges around taking the work that's been done, not just the work we're talking about doing in the future, but work that's historically been done, and actually implementing it, moving it forward, and actually deploying and gaining the benefits from it.
Yeah, thank you very much, Dave. Louise, I'd like to bring you in here from a kind of funding and investment perspective, because that must be one of the biggest challenges that you see within this space.
Yeah, no, absolutely. And just to echo what Dave said, that the early funding is always the challenge when you try and establish a circular business model, because overall it should pan out for the better, but you have to have that early funding. And I think right now, as an economy in the UK, you know, we need innovation, and to scale up, we need a push for funding and for policy, actually, to create an environment that is secure, so people know what's coming in terms of policy. You know, we've had some of the national commitments to net zero and so on, but not really to a circular economy. So that's a little bit interesting. And then secondly, you know, the funding and where government funding can help until we've scaled to a point where private funding can come in. But there's some new funding models in terms of blended finance that definitely will be needed and are coming into play here, I would say.
Brilliant, thank you very much. Bing, do you have any perspectives on the challenges that are faced in this?
Indeed, yes, thank you very much for bringing in on. This is actually one of the key questions that we're very interested in finding out by ourselves, and what are the perceived barriers to the circular economy from different stakeholders' perspective, and because obviously different group of stakeholders have different worries and concerns, and also that more importantly, how can our centre to address some of these barriers? As Jean mentioned, that our centre acts as a platform to bridge the gap among academia, practitioners and policymakers, and providing evidence and based recommendation that's of interest to wider communities. And so I just want to share a little bit on what we've done so far. And so we've asked the same question in two of our workshops in March. And the first one is organized by RAP and UKPP, which is the UK Plastic Pack Working Group. And the second one is at our centre industry engagement and lunch workshop. And so we've collected quite a lot of opinions and from participants, and few, you know, like, and there's, as Dave and Louise mentioned, there's some of the obvious ones, such as technical side, and there are barriers around creating new chemical recycling process, and there's also barriers around feedstock availability, quality, and competition from other sectors. And then how can we upscale and sometimes downscale some of those technologies, and that'll also be mentioned. And the other thing that is in terms of complexity of changes to business and in building a new value chains, because obviously that transition to a circular economy, it will induce so many changes to the system, and how business and you know, to deal with those risk versus reward and effectively is an important question. And then the other two things being repeatedly mentioned is economics viability. is a crucial barrier. There is the current lack of infrastructure, oil price volatility, and then as well combined with some feedstock availability, quality, all of these could affecting the business viability in terms of the investment. And then policy again is a critical barrier as well.
Okay.
So worked as enabler.
Yeah. Thanks very much, Bing. So we've mentioned consumers already, and I can see that there's a couple of questions have come in regarding consumers. So maybe we could just spend a couple of minutes specifically thinking about consumer knowledge and awareness. I'll pick up the questions from the Q&A in a second, but I guess, Peter, from your perspective, how important is that consumer knowledge and awareness, and how do we develop and create these new markets whilst informing them of where their products come from and the impact that they have?
No, that really is an important question, and we've done lots of studies over many years, particularly in the CO2 utilization market, and it's very easy as scientists to fall into the trap that people should know this, and it's the case that people don't know it, and we just don't communicate well enough. So we have Libby Gibson, who from Newcastle, who's working on communication strategy and engagement, and it's not public engagement, it's public acceptance. It's getting the public to accept what we're doing and realizing that it's good for them. On CO2 utilization, Covestro make a polyurethane, so a recycled CO2 into a plastic which is used in mattresses. People worry that they might asphyxiate, they might stop breathing because the CO2 might come out of the polymer because they don't know the chemistry. And that brings us back to policy as well, because things are changing, but 5 years ago, a lot of politicians had no scientific background. And it's a case of educating the politicians, both in terms of the technology and the economic and social benefit for the country. And it's no surprise that one of Britain's greatest achievements in the last year has been the vaccine rollout. And Nadeem Zahawi is a chemical engineer. So just take that on board.
That's brilliant. Peter, just to follow on from that, who do you think should take on the responsibility of that communication? Is it all of us within this community, scientists, industry, government, in order to help support that communication? How do we ensure that it happens in the pace that it needs to happen?
Yeah, that's absolutely right. It is interdisciplinary, as the title suggests. And I'm going to shout out to Louise again on Bankers for Net Zero. And I joined an APPG on fairer business banking, which I know nothing about banking, but I've learned a lot in the year that I've been on that. And you get politicians. I proposed this quadruple helix model where you have politicians, academics, industry, and finance all working together, because the more strands you put into that helix, the stronger it is and the more understanding there is. So absolutely important that we do work interdisciplinarily.
Brilliant. Thanks, Peter. And of course, I'd like to bring in Ian here, since we're talking about consumers. I guess in your perspective on how we can start communicating and the importance of that, raising awareness and knowledge of the consumer.
Yeah, I think I'd start actually by consumers, again, looking at data in front of me. Consumers want to behave sustainably. Not all of them, but the vast proportion of consumers, 70-odd%, want to behave sustainably. That's a sort of global market trend that we see. The point for some is they aren't able to. And in part, that's down to the affordability of the technology. So particularly in my sector, if I'm given a choice between a detergent which costs twice as much, am I really going to buy the one which is sustainable? So right back to the conversation with catalysts, making these technologies affordable such that consumers can do the behavior that they want to do is absolutely critical. I think then is the technology acceptable? Absolutely it is. So we've done a lot of work looking at what we call the carbon rainbow. So these different sources of carbon, whether it be plant-based or bio-derived, or from CO2, C1 capture, utilization, or even the chemical recycling into chemicals. Our initial work suggests globally people are really embracing those technologies, even waste into detergent, where we sort of said, really, people aren't going to go for that. They're embracing it. Now, what the gap is, they're saying, we like the idea, we don't believe you can do it. So the technology is acceptable, but it's not believable. And so that's the next piece, is this this continuing education. And I think, again, we through our company, through our brand communication, we can actually start bringing this into people's homes. And that's a sort of big role that we have to play. We demoed a product in China a few weeks ago where we have a laundry detergent made from captured CO2. And that just gets the whole dialogue with the consumers going, because all of a sudden, well, it must be believable because it's here, I'm using it, it's in my hands. It's not affordable today, but it gets the dialogue going to make things happen. So that's where we are.
Brilliant, that's really interesting. And just staying with you, Ian, because we've had a question come in from the audience that has asked about the confusion amongst consumers around biodegradable plastics, and also how biodegradability plays within the circular economy. Just wonder if you've got some perspectives on that.
Yeah, so I should call out my expertise is in the chemicals that go into the bottle rather than the chemistry of the bottle itself. so again, if I talk about biodegradable ingredients, again, the first thing is I think a lot of people don't really think about what happens to a product in my sector. If it's a shampoo or detergent, once I've used it, what happens? What's the fate? And what happens, of course, is ideally those materials go into the sewage treatment and they do biodegrade, so that they biodegrade to CO2, they biodegrade to biomass, and they biodegrade to water. And you hope that therefore there is no contamination of water as a consequence. But of course, then you've got the link back. So that's where the CO2 comes from in my business. If you forget about the energy consumption used in the manufacture, which I'll park as another job to be done, that embedded carbon, which then generates CO2 at end of use, that's the link back. And then that takes us into the world of Peter with, well, can I capture carbon dioxide and make that a completely, probably in the circular economy models we saw earlier on, it's really at the outside of that loop of what's going on, but that's the bit that we're trying to drive.
That's great, thanks, Ian. Dave, I don't know if within your cluster this kind of biodegradability issue and how we talk about it as consumers, if you've got any perspectives from your side.
Not directly, but some of our manufacturers are down the chain in terms of bottle manufacture. So they are very much looking towards how can they increase the recyclability. How can they use recycled plastics in the supply chain? And I think it's an interesting one. When you start talking about biodegradable, to some extent, you do lose some of that recyclability because it is actually degrading, and it makes it much harder to get that back into a circular chain. Some of the things which have been talked about in terms of degrading purely to CO2, yes, there's interesting, comments, and it might fit in with what Peter was saying about direct air capture. But I think it's a quandary we need to face, and I'm not sure it's a quandary industry and scientists may be able to answer alone. I think it involves a lot of different, disciplines to understand which is the best way. We know what we want to do, but in the short term, which is the most productive way of getting there.
Brilliant, thanks very much, Dave. And I'm going to stay on, Bing, you wanted to come in there?
So I was just trying to unmute myself. Yes, thank you very much. And yeah, so it's really interesting point about consumer knowledge and awareness and their role in developing and creating new markets. And indeed, that we're working together with RAP and then to gauge and to understand consumers' knowledge and then their acceptance and their perceived benefits and concerns of those products. And so, and then ultimately is the willingness to pay. And so I think all of this is very, very important. And another thing that I would like to highlight is actually the financial literacy is also it's very, very important. And I think there's a need to raise more awareness and knowledge about, and also more discussions about our savings and pensions and investments, and to connect the minds of citizens and between the need for action for companies in their savings and pension products. And I think this is general, not necessarily just a circular economy, because quite often that how should your pension be invested? And in the UK, there are 2.6 billion or trillion invested in the UK pension. Much of those funds goes into industries such as fossil fuels and tobacco and arms and gambling, and also contributing to deforestation. So I think there's an urgent need for all the, for example, the pension funds tell the savers and how their money is invested and what it means for people and planet, and then what have they done to take in the environmental, social, and governance risk into account and ensure their portfolios are consistent in line with the Paris Agreement. I think this is another different set of consumer or consumer knowledge and awareness.
I can see Louise is wanting to come in on that as well. Louise.
Yeah. Can I just add some really, really interesting points? And what's just struck me is every company, scientists, the government, NGOs, we haven't mentioned NGOs very much, are all important in educating consumers. And it feels like there are two levels. One is it has to be super simple. And Ian's example about a detergent showing, having a simple example that's very tangible is one hugely important piece, because you can get mattresses, you can get vodka, again, very expensive. Nobody's really scaling it yet. So that's one piece. But the other piece, which links to, again, I'm going to point at Unilever and sort of purposeful companies, is that telling the story of the system. What happens with biodegradability? The fact that there is a circular system and where your money goes is going to fund something. All that, if we can convey that circular piece in an easier way to consumers, I think that's the next step. So one is examples, and two is this is a systems challenge. And actually, the best way to talk about a systems challenge is to have a joint goal, which 71% of consumers want to solve climate change, at least, and certainly the next generations do. So let's use that to shift the thinking, so it's not just a product, but it's the whole system that they're helping to contribute to.
Yeah, I feel like we could talk about consumers for a lot longer. No, it's really great discussion. Thank you all. And I can see that there's a couple of other questions come in, but there's a couple of other big juicy topics that we wanted to touch on, and I'm very conscious of the time to make sure that we give policy and waste equal measure. But just wanted to, because we've mentioned direct air capture a couple of times throughout the conversation so far, and there has been a question come in from the audience around this. So this is from Phil. He says, shouldn't the methanol economy from DAC to CO2 be supported by government and UKRI as much as the hydrogen economy is being supported? Because methanol plus direct methanol fuel cells is a more sensible way of closing the carbon cycle for fuels than compressed hydrogen. So yeah, I guess it's the question is asking about the balance between supporting the methanol economy versus the hydrogen economy. I don't know, Peter, if you've got a perspective on this.
Yeah, absolutely. So it's really important. I think too much emphasis is on the hydrogen economy. Hydrogen is incredibly important, but as a vector, everything is an energy vector. So it's difficult to store electricity, except diurnally, because batteries discharge. My car sat outside, it's had diesel sat in it for 6 months, the battery's dead. So the diesel will stay there. I think methanol is a great economy. I would also look at the synthetic fuels economy. And as Richard will know, we contributed towards the Royal Society report on synthetic transport fuels. If you take, looking at methanol, if you take the methanol fuel cells, you have to redesign the car. And I know a lot of work is going on in redesigning cars, but this brings in policy, it brings in direct air capture, and it also brings in the social aspects. Because as we abolish new combustion engine vehicles by 2030, there's still going to be a legacy of old combustion engines going, diesel will go till 2050, 2060. And we run a risk of creating a social underclass that people can't afford to run electric cars. The life cycle assessment on electric vehicles is not good. If you buy a big EV, you might as well buy a small diesel. Because the full life cycle assessment over the whole system is so difficult. But direct air capture coupled with synthetic fuels, I think that is the real future in the short term. And remember, this is a transition. This is not 2030, we all stop, we all go electric. There is going to be a transition, and we need to fuel that transition. But fuel's maybe not the best word, but we need to ease that transition so that we don't create ourselves more problems. And I think direct air capture will come up later, but I think it's really important that we do look at that.
Excellent, thank you, Peter. And Ian, I think you might have a opinion on this as well.
Yeah, I just wanted to reinforce this link between we have a sort of an issue in the UK of sectorizing fuels and chemicals as two separate different things, and yet when you go back, the underpinning science and the underpinning technologies are identical. And so I'm already running into, I have to say, not in the UK but in the EU, I'm running into collaborations with partners where they're saying, look, I'll give you an example. We are making benzene. Okay, I want sustainable benzene. We have it, but you can't have it because we're feeding it back into our crackers because it's more value adding to make it into fuel because of the incentives of the fuel economy that aren't there for chemicals. In the UK, we've got a chance to get that right so that we can incentivize both the fuels and the chemicals. So I just wanted to add that that piece to the puzzle, because the science we've got is brilliant, but let's just not fixate on fuel.
Yeah, because they're all chemical molecules, and it's how we use them that's the point.
And again, my existing supply chain today, I source my hydrocarbons from a tanker of kerosene. I take the cut of the kerosene that the aviation guys don't want because it freezes at too high a temperature, and that's a non-branched kerosene molecule which then forms a detergent, and I want it because it's the non-branched materials which biodegrade. So there's a win-win in the current sort of symbiotic relationship, which if we can get it right, we can build it into the sustainable aviation fuels and chemicals in the future. It's there to be had, kind of.
Yeah, it's a massive synergistic, interdisciplinary opportunity. Thanks for pointing that out, it's brilliant. So you've just mentioned their incentives on fuel, so I'm just going to move on to the policy and incentivization and kind of that whole approach and how actually policy can support this move towards a circular economy. So Bing, I know that you've been doing some work on this.
Yes, and yes, I am the team leader of policy team 3, but actually Peter is the one doing most of the work. So, but I think policy plays a critical role in moving towards a circular chemical economy to accelerate and supply more sustainable products and changing demand behavior, and also enhancing investment. And obviously the question is, how can we turn effective policy ideas into action to facilitate an orderly transition? So I believe, and obviously we need to looking into from both the supply and demand side, and on the supply side that we need to understand what motivated and as well as what prevented business to engage with a circular principle. For example, quite a lot of the thing we've heard in this the manufacturing product through the circular economy-based practice, a lack of financial feasibility relative in relation to the linear products, and costs are much more expensive than if we just actually buy from the virgin material. So I guess then there isn't any incentive, because obviously so we need to look at the policy intervention. For example, there's been VAT relief being talked about for reused products, and for those having a certain percentage of recycled content, for instance. And also that how can we facilitate development of a circular trading platform, for example. And the other enabler obviously come down to financing, and then how can we offer easy access to finance for innovation, circularity. Maybe we need to have more low interest or zero interest for circular projects, and they're tailored made and financial products. And in the UK, we've been talking about mandates and for disclosure of climate related information, TCFD. And how can, obviously, besides the internally external funding source, and how can business and to do more, especially those profitable ones, for instance. And I think all of these points are really, really important. As I mentioned, Peter is our policy guru in the center, and then he has made many engagements, and I'm sure he has a lot more to add on to this. Thank you.
Peter, would you like to add any comments?
Yeah, just a few. So I've just written a report for which going in APPG energy studies, and the tagline is "Follow the science, not the sheep." A lot of policy at the moment is they're doing this, so we'll do the same, and they're really not looking at the whole picture. It's a symbiotic environment, and I'll just give you one example. I always like using props, so there you go. Ubiquitous in the last year, hand sanitizer. Okay, that's made from CO2. But if you look at the whole system, it's made from CO2 that's been direct air captures. It's actually New York air that's been captured. The hydrogen comes from a electrochemical cell where water's split to give hydrogen, which goes into making the ethanol, and also oxygen. And we've had a shortage of oxygen. So if you look at the COVID situation, this was actually a vodka company, and they repurposed making vodka into making hand sanitizer. And if anyone says it's not financially viable, they were giving this away free to New York hospitals. But look at the whole system. You have the hand sanitizer, you have the vodka to celebrate at the end of the virus, but you also have the oxygen being produced that can go to help with respiration. So it's a case of policy looking at the whole system and not the silo.
Yeah, that's a really good point. Thanks, Peter. And Dave, from your perspective in kind of an industrial cluster, how can policy support businesses within that space move towards this circular economy?
I think we've talked about business models and the financial changes and implications, but I think also if you start thinking about some of the policy drivers which are out there, how circular economy can help achieve those. Probably in the last 6 months, we've probably focused quite significantly on supply chains and securing those supply chains. We've had concerns over Brexit. We've had concerns over COVID. We've had lots of different things. And if we can keep some of those materials we've already made, reuse those as a raw material back into a process, then that does help secure some of those supply chains. And I think it's understanding the government's drivers and clarity. Are we really bothered about a circular economy, or do we want to stop climate change and preserve the environment we have? And if so, which is the best tool to do it? We've talked about different tools here, and I don't think there is one silver bullet which will get us to the end solution. We've got to pick the best tool from quite a wide toolbox and use that one. And sometimes that's where there's conflict or concern of what future policies and business models might be. So I think, it's driving that change in the right way and making sure we get what I think we all want around this table.
Yeah, brilliant. Thanks very much, Dave. So just kind of leading on from that, I'm going to pick up a question from Jeff that's come in, that's specifically talking about waste and regulation around that. So Jeff says, chemical recycling straddles different regulatory environments, taking waste regulation to product, REACH, UK REACH, for example. Is clarity on sector regulation key to attract and de-risk investment? And what needs to happen to ensure optimal regulation for this nascent sector happens? For example, resuming the EA's end of waste service. So I think this is about sort of de-risking investment via regulation. And Louise, I'd like to bring you in here if you've got a, does that regulation and sort of clarity on what's coming help de-risk investment?
No, absolutely. I think that's the key. So in the work we've done at Bankers for Net Zero, that is really what keeps coming up. In order to transform whole industries, the policy needs to be, and Peter said it, holistic, and it needs to have, there needs to be a plan. So it isn't, oh, we have to reach this number by this date. There has to be ratchet mechanisms to just really incentivize the behavior we want. I thought Dave's point about, do we want a circular economy or do we want to stop climate change, is a really, really good one. Because again, it's that holistic approach and giving the, nobody will invest if they don't know what's happening. Nobody will invest if they, whether it's hydrogen economy or another economy, if they're not sure whether this is going to be punished. So many people, even consumers, got bitten by buying diesel cars because that was better for the environment. Now they have to ditch them. And of course the science isn't clear necessarily of this is going to last forever, but government has to have a clear policy on these things to give the security, I think. And then again, incentivizing systems behavior, like being talked about, you know, how do you create a trading platform? Just incentivizing those things. And then, you know, everybody, you know, the funding bit again, which is around, can you front load market support so that you can then crowd in the private support after.
There's been a couple of related questions that have come in, and one is around, so how about international agreement on standardizations of assessment, and does that support an internationalization of the circular economy? I don't know.
I kind of want to point slightly to Peter, because this is where the international work on the life cycle assessment and also techno-economic assessments come in, where there has been quite a lot of collaboration internationally. But I'm going to point at Peter for the detail.
Yeah. Peter.
Thanks, Louise. So yeah, it's really important because you know, this is a global problem. There's no doubt it is a global problem, but there are different entities within the globe. It's all very well doing that standardization, and yes, we are working on that on the techno-economic side. But we have to realize that there are some countries where it will be difficult. Setting the standardization is important, but then we need to look at things like overseas aid and tariffs for developing countries, because what we don't want to do is disadvantage those countries who can't afford to do what we're planning to do, because this is not going to be cheap. And yeah, Ian at Unilever mentioned I think the 1 billion euro investment by 2030. There's the Elon Musk Foundation. There's lots of work going on in pockets, but we have to realize that, you know, what we do in the US or the UK or Europe is different from what can be done in sub-Saharan Africa or in parts of Asia. So we need to be very careful that we're not too prescriptive.
That's great, and I'd like to actually bring Ian in here as a representative for a global organisation with markets all across the world. Would standardisation support, or could that be a hindrance in some points?
Yeah, I think again, this is outside of my expertise area, but generally I think sort of prescriptive standardization often leads you down a path where you end up not having what you want, because you suddenly realize later on, oh my goodness, the regulation's driven me in the wrong direction. So I think guidance and standardization and guidance and what to think about is really useful, but reticent sometimes on regulating it and sort of casting it into thou shalt. For example, LCA, you will do an LCA this way, regulated, I think would be a disaster. A guidance on the sorts of things you should consider as a sort of standard approach, spot on, but not really in my not my field of specialism, that one.
Excellent. And then I do have another question, which Ian might be appropriate for you. So one around replacing plastics with metals. Can't metals replace plastics in certain applications?
The easy answer is yes. So some people will be aware of the loop activities that are going on, the various sort of activities looking at. Dove has now got an antiperspirant that's sold, I think, in a metal can instead of a plastic can, with a closed loop recycling, hence the loop name. I think there was another question in there about sort of the reuse of packaging in general. So again, activities, I don't want this to become a sort of Unilever show because lots of people are doing this stuff, but looking at refills where there's a sort of a keeper bottle which you use time and time again, but then a small concentrated refill that you use to fill the product, huge plastic savings in that type of space, which we're looking to roll out across different innovations. So I think all these models are absolutely, as Peter said, the sort of reusing things before you recycle things where you can, absolutely. And then this hierarchy, the Lansing hierarchy, absolutely applies.
I suppose one of the key limitations from that is the infrastructure that is within different countries and within where you're deploying those reuse loops.
Yeah, so again, you asked earlier on about the plastic piece. So, I mean, we have a target to sort of move towards 100% reused, recycled or composted. And I keep looking at that saying, well, which is it? And of course, even from my lens, it's like, well, which is it? Is it reuse, recycle or compost? And of course, the answer is, well, it's all of those depending on where you are, it is the answer. And so things that work in the UK geography might not necessarily work in South Asia or somewhere. because of the infrastructure isn't there to deliver it.
Brilliant, thank you very much. So got a couple more questions. I can see there's a few come in, and we haven't really touched so much in this panel session on LCA. It's come up a couple of times, but there is a specific question on LCA. For the LCA, how about the time scale involved in the whole process? And I guess I'm going to look to Peter to come into here. I guess Ian's just made a comment about, prescriptively defining the LCA boundaries. So I guess what's your perspective on that?
So I read the question and took two perspectives on that. The timescale for LCA to do an LCA, or the timescale for the sequestration and the recycling. So in terms of, if it's the simple one, how long does it take to do an LCA? A good one, minimum 6 months, and you have to have lots of good, reliable, robust data. In terms of mitigation potential, for example, often for CO2 utilization, it's quoted as 100 years sequestration. Now, if you're in a circular economy, that really doesn't apply, because the true circularity means that timescale is independent, because you're in a cycle. So you can't put a timescale on a cycle. But that relies on a robust life cycle system. So I would say don't get hung up on the time of the life cycle, but the longevity of the life cycle. How many times for a catalyst? You talk about turnover numbers and turnover frequencies. In terms of LCA, the turnover frequency is how quickly can you recycle something. The turnover number is how many times can you recycle it. But again, like I say, circularity is limitless in time.
Brilliant, thank you very much. So there's a couple more questions about consumers here to pick up. So one's interesting one, which I'm going to look to Bing, I think, to help answer, is so we talk a lot about incentives and rewards, but how about punishment mechanisms? And I suppose this is kind of related to a carbon tax or sort of something specifically like that. Is it worth researching these kind of punishment policies or models within this model, this circular economy?
Yeah, indeed. I think one thing that we need to look at is to have an in-depth review on what the carrot and what are the sticks available, and then what we can do next is to looking at the relative and attractiveness on those policies. So we could do a sort of a simulation on to looking at impact by implementing those potential policies in place.
Great, thank you. There's also a couple of questions here about government policy and the impacts that it has. So there's one here on waste with the question, so chemical recycling isn't defined in the UK law, and it doesn't feature in DEFRA's waste hierarchy. Given the government's green reputation is centred on the Environment Bill, would the panel expect to see more ambition and even a mention of chemical recycling in the text? So how could we, I guess, influence DEFRA's waste hierarchy policy, and would you expect to see chemical recycling come into play there? I don't know if anyone's got a specific opinion on this and would like to raise it, Louise?
Not really. I guess the difficulty with, so on one hand, yes, of course it should be there. The difficulty is with up and coming innovations and new technologies is that it can really skew what happens next if one is picked up, if you get very specific on this rather than the general idea. So I would say yes, that it would be weird if chemical recycling didn't start featuring. But at the same time, I would suggest at this stage, we are in this transition process where there are lots of different competing variations on things. You don't want to be too specific and box out something that could have legs later or more impact. But I'll leave it to the chemist to decide which one that is.
Dave, you've got...
Yeah, I was just certainly backing everything Louise has said, but I think we need to make sure that it doesn't rule out the circular economy. as sometimes has happened in the past with end of waste criteria. So I think it's very much, taking it forward and making sure, and we touched on it earlier, about the punishment approach. We've got to be careful with taking a punitive approach because we're a global, market, and a lot of our members' biggest competitors are their own sites in different countries. So we've got to make sure that any punitive actions are appropriate and really act to encourage the circular economy.
Yeah, it's a really good point, Dave. Thank you. So I'm really conscious of the time. We've got a few minutes left, and something I'd just like to touch upon before we do say goodbye is we've talked a lot about the circular economy and moving towards that. Now, equality, diversity and inclusion is becoming more and more important across society and is becoming a bigger issue across different levels and institutions across society. How can we as a community ensure that these values are embedded in a chemical circular economy, ensuring a fair and just transition as we move forward? I personally think it's a really important topic and one that we should consider in everything that we do. So I'd just like to hear some of the panel's views on this. Ian, I'd like to bring you in first, if that's all right.
Yeah, and it goes back to the point I made on affordability. So I think the link between affordability and social injustice is obvious. If I can't, and so it's absolutely cannot be that sustainable products are only affordable by the wealthy. It doesn't work for the planet. It's just completely wrong. So I think I only have a very simple answer to that one, which is that the solutions have to be affordable and therefore available to everybody, both within the UK but also globally. Why shouldn't a consumer in India who's hand washing their clothes have a sustainable product? Why should it only be a UK consumer with a top loading washing machine or a front loading washing machine, or even having somebody else to wash their clothes if they're in India? So that's my only kind of comment on that. To me, it comes back to this affordability piece is a key driver there.
Brilliant, thank you. Louise?
Just going to build slightly on that, and that we've talked about the opportunities for businesses of circular economy and the chemical circular economy in particular. And if in order to create business models that can scale and deliver on that opportunity, you need the diversity, because you need the diversity in the audience and your consumers. So hopefully that the consumer piece is so important, and consumers are diverse. Even in the UK, we can sit in a bubble somewhere and actually not create things that will drive behaviors in other parts of the UK, let alone in India. Yes, it's hugely important.
Brilliant, thank you. So I think we have time for one more comment. Bing, would you like to?
Yeah, sure. So I think, and obviously the EDI is embedded throughout our center, through our research, that we're aiming to provide recommendations on how the proposed circular economy can achieve the Sustainable Development Goals objective by addressing inequality, exclusion, and more importantly, empowering local businesses, SMEs. For example, that know that 97% of business in chemical sectors are SMEs, and we need to work closely with them to understand their concerns, barriers, and opportunities to adopt the circular business models. And also we've also touched base around the wider community as well. In order to have the wider spread adaptation of circular principles, it requires a focus on embedded circular skills and extensive technical skills as well. And so I guess the universities and local authorities have an important role to play here in providing the necessary training, skills, and innovation needed to abide the employers in the UK. And we as a society, we need to contribute towards to addressing inequalities by addressing some of the barriers faced by certain groups, age, disability, ethnicity, and gender, by offering their fair and access to skills and training job force.
Okay, brilliant. Thank you very much. So I'd like to just thank the panel for this session today. It's been really interesting. Some really great views, I think, have been shared. And thank you to the audience for your excellent questions. I hope you've enjoyed it as much as I have. And I'd like to now hand back over to Jin, who's going to close today's session. Thank you.
Thank you much, Sheena, and also thank you for all the panel members. I really enjoyed this this panel discussion. So I think this is towards the end of this national launch event. So we started from talking about the role of science and innovation as addressed by Richard's keynote. And then in the panel discussion, we extend this into, for example, the whole system approach, and we talk about various non-technical barriers, such as finance, business model, policy and publics, and we also touch the EDI aspect. So that's exactly our center is going to address in the next 4 years. So I would like to stop here and to thank you all for the speakers, for the panel chair and the panel members in bringing these interesting topics. And I would like to thank all the attendees. Thank you very much for your time this morning. I hopefully you enjoyed the section as much as I did. And I would also like to use this opportunity to thank the organizers, the technical support, and the CE Hub in bringing all these interesting events together into this week. So after our center, there's a few more sections. If you're interested in other resources flow, I would really recommend you to join other sections, and also the national launch of the CE Hub on this Thursday. So again, thank you all for joining us today. If please do keep it, sorry, so just last word. So please keep in touch. And if you have any queries, or you want to express your interest in receiving our updates, please send an email through to our email address that's up here in the chat box. Thank you very much.